We will now continue our discussion of chapter 10, which is on Heron's formula. And as you may recall from the previous lecture, that Heron's formula is used to calculate the area of a triangle given the sides of the triangle. So normally the area of the triangle formula is half base into height. And in situations where we do not know what is the height of the triangle, and if we know only the lengths of the three sides of the triangle, in that case Heron's formula comes in handy to calculate the area of the triangle if we know the lengths of the three sides of the triangle. Now in this question, which is the first question from exercise 10.1, we are given that a traffic signal board has the shape of an equilateral triangle and the length of the side is A, and we know that equilateral triangle has all sides of equal length, so that means each of the three sides has a length of A units, and we are asked to find what is the area of the signal board using Heron's formula. Basically, since we are given the length as some parameter A, we will get a general expression for the area of the equilateral triangle using Heron's formula. And then in the second part of the question, we are asked to find the area of the signal board given its perimeter. So from the perimeter, we can find what is the value of A, and then we'll substitute that in Heron's formula to compute the area of the signal board. Okay, so first of all, we are given that the length of the side is A units, so we can find the let us first write down what is Heron's formula. So area of the triangle, area equals S into S minus A into S minus B into S minus C under the root. Okay, this is the general formula for Heron's formula for calculating the area of a triangle. But because we are given that it's an equilateral triangle, we know that A, B, and C are all equal to the same A. So since the triangle is equilateral, we have all the three sides to be equal. A equals B equals C. So we'll simply call it as A, in which case the value of the area, or the expression for the area in this case, will become S into S minus A into S minus A into S minus A, because all the three sides have the same value of A, right? So we put that under the root as well, so we need to put the square root here. So we have this now, this expression now for the area of the triangle, okay, for the equilateral triangle, that is. Now we can find what is S from this expression. Okay, so what is S? S is the semi-perimeter of the triangle. So the parameter S in the Heron's formula represents the semi-perimeter, that means it is half the perimeter. And since we have the side of the equilateral triangle given as A, so S will be the sum of the three sides, which is A plus A plus A. All the three sides have the same length A, so the perimeter is A plus A plus A, and the semi-perimeter is nothing but the perimeter divided by 2, so we will get it as 3 by 2 times A, which is 3A by 2, right? So that's our value for the semi-perimeter parameter S. Now once we have this, we can now substitute this value in the expression for the area. So area is we have S into S minus A into S minus A into S minus A. So in place of S, wherever we have S in the expression for the Heron's formula, we'll substitute 3A by 2 and see what we get. So in place of S, we get 3A by 2, which is nothing but 3 by 2A into S minus A. I need some more space there, so let me write it a bit closer. So 3 by 2A into S minus A, which is S is 3 by 2A minus A. Similarly, we have S minus A again, which is 3 by 2A minus A into, again, it's 3 by 2A minus A. And all of this is going to be under the root. So basically what we have here is the first term is 3 by 2a. The second term is 3 by 2a minus 1a. And you know that 3 by 2 is 1.5. 1.5 minus 1 is 1/2. So 3 by 2 minus 1 is 1 by 2. So we'll get the first part here as 1 by 2a. And similarly, the next one is also 1 by 2a. And the third one also is 1 by 2a. So all of these are under the root. So basically the area equals, so we can just take out the terms. We'll take the numbers out separately and the a parameter separately. So we'll have 3 by 2. I can write the 3 by 2 as 3 into 1 by 2. So for the first 3 by 2, I'm writing that as 3 into 1 by 2. Then we have the 1 by 2, 1 by 2, 1 by 2, 3 times. So we'll write them 3 times. So 1 by 2 into 1 by 2 into 1 by 2. And then we have the a term, a into a into a into a 4 times. So we'll have a power 4, that is. Okay, a 4 times we'll have a. So a into a into a into a. And all of this is under the root. So we can simplify this expression. So wherever we have some number occurring twice inside the root, we can take it outside and replace it with a single time, right? So we have only 1 3, so we'll keep the 3 inside the root. The number half, 1 by 2, is there 4 times inside the root. So if we take it outside the square root, it will be appearing 2 times. So it will be half into half. And similarly, the parameter a is appearing 4 times inside the root. So we can take it outside the root and make it 2 times. So into a into a. So what is left inside the root is just root 3 now. So we'll get the expression as 1 by 2 into 1 by 2 is nothing but 1 by 4. A into a is a square. So 1 by 4 into a square is a square by 4 into root 3. So we have basically obtained an expression for the area of equilateral triangle given its side length. So the side is given as a units of length. So from a units of length, we can calculate the area of the equilateral triangle. Using the Heron's formula, we obtain this expression as a squared by 4 into root 3. So we will use this expression to find the area of the triangle given its perimeter is 80 centimeters. Okay, so since we are given now for the second part of the question, perimeter equals 180 centimeters, not degrees, so that's 180 centimeters. So if the perimeter is 180 centimeters for the equilateral triangle, then each side, which we call as A, equals 180 centimeters divided by 3, because the triangle has 3 sides and all the 3 sides have equal length. So we divide the perimeter by 3, so we get the length of each side as 60 centimeters. So now that we have the length of each side as 60 centimeters, we can substitute this in the expression for the area and calculate the area. So therefore we will get area equals a square root 3 by 4. So a square means 60 square, so that's 60 into 60 by 4 root 3. Okay, so we just need to simplify this and we will have our answer for the area. So that gives us a value of 900 root 3. So 900 root 3 centimeter square is the area of the triangle given its perimeter is 180 centimeters. Okay, so basically what we have done is we have used Heron's formula and used the fact that all the three sides of the equilateral triangle have the same length A, and then simplified the Heron's formula to get an expression for the area of the equilateral triangle. Okay, so if we know the side of the equilateral triangle as A units or A centimeters or A meters, whatever it is, then the area of the equilateral triangle is A square divided by 4 into root 3. So it's A square root 3 by 4. So using that, we have now computed the area of the equilateral triangle, whose perimeter is given as 180 centimeters. So from that, we computed the length of each side, and we obtained that as 60 centimeters. So the area is 60 squared, which is 60 into 60 divided by 4 into root 3. So we get that as 900 root 3 square centimeters. Okay, so that's the area of the equilateral triangle. Let us now do one more example from the exercise, and we will now do question number 2 from the exercise 10.1, wherein we are given the dimensions of a triangular wall which is used for some advertisement. So the dimensions of the triangular wall are given as 120 meters, 22 meters, and 122 meters, 22 meters, and 120 meters. And it is given that the wall, the cost of advertising on the wall costs 5,000 per square meter per year, and we are asked to find what is the cost of advertising on that wall for 3 months. Okay, so basically we'll first find the total area of the wall. Once we find the total area of the wall, we can find the total area using Heron's formula, because we are given the three sides of the triangle. So by using Heron's formula, you can find the area. Once we have find the total area of the wall, we will multiply the total area by 5,000 to get the total cost of advertisement on that wall for a year. So because we are given that each meter square costs 5,000 rupees. So if you multiply the total area of the wall by the cost per square meter, we'll get the total cost of advertising on that entire wall per year. So once you have got the cost per year, we can divide it by 12 to get it for each month. And once we have obtained it for each month, we can get it for 3 months by multiplying it with 3. So that's the procedure we are going to adopt to solve this problem. Okay, so let us first compute the area of the wall. So we are given the three sides. So let us call the three sides as A, B, and C. So let's have the A value as 122 meters. And let us call B as 22 meters. And the third side C is 120 meters. So let us first compute S. So we know the S in the Heron's formula, or let me write the Heron's formula expression first. Area of triangle by Heron's formula is S into S minus A into S minus B into S minus C under the root. And we know that S is nothing but the semi-perimeter. So S equals A plus B plus C divided by 2, which is 122 plus 22 plus 120 divided by 2. So we get the value of S as, so we get that value for S as 264 divided by 2, which is 132. So we have got the value of S. Now we can substitute this in the expression for the Heron's formula to get the area. So I'll just write it as area equals S into S minus A. So S is 132 into S minus A is 132 minus 122 into S minus B is 132 minus B is 22 into S minus C is 132 minus the value of C, which is 120, and we have all of these under the root. So basically that becomes 132 into 132 minus 122 is 10. 132 minus 22 is 110 into 132 minus 120, that should be 12. Okay, so we have these under the root. And now to simplify the calculation of this square root, we can break down these numbers into simpler numbers. For example, we can write the 132 as 11 into 12. So 132 is 11 into 12. So that's the 132 part. The 10 will keep it as a 10. Then we have the 110. So the 110 we can write it as 10 into 11. So 10 11s is 110. And then we have the last number 12 as it is under the root. So when we have numbers under the root as products, anything that appears twice under the root, we can take it outside once and get it outside the root, right? So we have 11 appearing 2 times, 10 appearing 2 times under the root, and similarly 12 appearing 2 times under the root. So we can take them all outside the root and replace them with a single repetition. So that will be basically, there are 2 11s, so we'll take the 2 11s outside the root, it becomes 1 11. And similarly there are 2 10s, we'll take it outside the root, so that will become 110. And there are 2 12s under the root, so we'll take it outside the root, and that becomes a single 12. So this product is now the area of the triangle. So that gives us an area of 1320 meter square, 1320 meter square. So that's the total area of the wall. So we have the area as 1320 meter square, and we are given that the cost of advertising is 5,000 per meter square. So for 1320 meter square, it will be 5,000 into 1320, and that will give us the cost of advertising per year. So let us proceed and compute that. So let us write, we have area, we have calculated the area as 1320 meter square. We know the cost of advertising, cost per meter square, is given as rupees 5,000 per year, that is. Yeah, so we are calculating 5,000 per year. So total cost will be, total cost per year will be 5,000. So that's rupees 5,000 into 1320. So that's the total cost per year. So we are interested in finding it for 3 months. So let us now calculate cost per month. So total cost per month will be the total cost per year divided by 12, because we have 12 months in a year. So that is cost per year divided by 12. So that will be 5,000 into 1320 divided by 12. So that is the cost per month, and we now need to calculate the cost for 3 months. So we can simplify this and get the cost per month. So 12 will go here 11 times in 132, so we get 5,000 into 110, and so that gives us a value of 5,55,000. So 5 11s are 55, and then we have the 4 zeros. Okay, it's 5,50,000, right? Not 55. 5,50,000. Okay, make this correction. So we have 5,50,000 as the total cost per month, and we now need to calculate the cost for 3 months. So the total cost for 3 months cost for 3 months equals the cost per month into 3. Okay, so we have 5,50,000 per month into 3, so that will give us 16,50,000, right? So 16,50,000 rupees is the cost for 3 months for advertising on that wall. For 3 months, it is going to cost us 16,50,000 rupees. Given that the cost per square meter is 5,000 rupees per year. Okay, so we have now calculated the total cost of advertising on that particular wall for 3 months. So we were asked to find how much rent the company would pay to hire the wall for advertisement for 3 months. So we first calculated the total area of the wall. From the total area of the wall, we calculated the total cost of advertising for a year by multiplying the area by the cost per square meter, which is 5,000. And once we got the cost for the entire year, we divided it by 12 to find the cost for each month. And once we obtained the cost of advertising for each month, we obtained the cost for 3 months by multiplying the cost per month into 3. So that gives us the total rent that the company will have to pay to advertise on that wall for a period of 3 months. Okay, so that completes this example as well, and we will now do one more example from this exercise. And because this chapter is a relatively simple chapter and a short chapter, we will not be working out all the exercise problems. I will do so. I'm doing only a few of the problems. But if you have any questions regarding any other exercise problem, please post it in the comments, and I will try to clarify that in a separate video. So let us now do one more example for this chapter, which is question number 5 from the exercise number 10.1, where we are given that the sides of a triangle are in a certain ratio, 12:17:25, and the perimeter is given as 540 centimeters. So we want to find its area. Okay, since the ratio is given as 12:17:25, we will have 12x. So the perimeter can be written as perimeter will be 12 times x plus 17 times x plus 25 times x, and that is given to be equal to 540 centimeter. Okay, so x is the single unit of that perimeter, and each side is having a certain multiple of that single unit. So one of the sides is 12 times that single unit, the other side is 17 times that single unit, and the third side is 25 times that single unit. So the total perimeter is 12x plus 17x plus 25x, and that value of the perimeter is given to us as 540 centimeters. So 12x plus 17x plus 25x happens to be 54x. So we have 54x equals 540 centimeter. So from this we get the value of x as 540 divided by 54, which is simply 10 centimeters. Okay, so now that we have the value of x as 10 centimeters, we can calculate the length of each side. So length of each side is, let's say the first side A is 12x, so 12x is 12 into x is 10, so we get 120 centimeter for the first side. The second side, which we can call as B, is having 17 times x, so that is 17 into 10, so that's 170 centimeter. And the side C is 25 times x, so that's 25 into 10, which is 250 centimeters. So now we have the lengths of the of each of the sides of the triangle, and for the Heron's formula we need to calculate S, and we know that S is the semi-perimeter, which is nothing but the perimeter divided by 2. So we are given the value of the perimeter as 540, so perimeter by 2 is 270 centimeters. Okay, so we have now got the values of S, the three sides A, B and C. We can now apply Heron's formula and calculate the area of this particular triangle. So let us first write down Heron's formula. So area of triangle is square root of S into S minus A into S minus B into S minus C, and we have the value of S as 270 centimeters, so that will be S is 270 into S minus A will be 270 minus 120, so let's substitute that. So it's 270 minus 120 into S minus B will be 270 minus the second side B is 170 into S minus C will be 270 minus the third side, which is 250, and this is all under the root. So we will have 270 into 270 minus 120 is 150 into 270 minus 170 is 100 into 270 minus 250 is 20, and all this is under the root, and we just need to simplify this root to get the area of the triangle. And now we can simplify this calculation, so we can write this 270 as 27 into 10. Similarly, the 150 we can write it as 15 into 10 is 150, and the 100 can be written as 10 into 10, and the 20 can be written as 10 into 2 under the root. And we know that whatever appears twice under the root can be taken out as once outside the root. Okay, so we have the number 10 appearing 4 times, so that's one pair of tens, that's another pair of tens, and so we can take those two outside, so we'll have 10 into 10, so we have taken these two which are in pairs outside the root, so they come outside the root as 110 and another 10 here. And then we have the 27, so we'll leave those terms as it is. So what is left under the root is this 27 into 10 into 15 into 2. Okay, so that gives us 10 into 10 is 100, square root of 27. Let me write that properly. Square root of 27 into 10 into 15 into 2. Okay, so that's our expression. Can we simplify this further? We might be able to do a further simplification here. Let's see what we can do. We can write this as 100, and under the root the 27 can be written as 3 into 3 into 3. That's 27. The 10 we'll leave it as it is. The 15 can be written as 3 into 5, and the 2 will be left as it is. So now we see that there are 4 3s, so there is one pair of 3 here and another pair of 3 here, so we can take each pair outside, as a single one when we take it outside the root. So it will be, let me change the color of the font. So it will be 100 into 3 into 3, and what's left inside the root is 10, 5 and 2. So into 10 into 5 into 2. So we have 3 3s are 9. 9 into 100 is 900. And the 10 can be broken down further as 2 into 5. And then we have the other 5 and the 2. So now we see that there are a pair of 2s and a pair of 5s. So we have 2 5s and 2 2s. So we can take them outside the root as only one time. So that will give us 900 into 2 into 5. So 900 into 2 into 5 is 1800 into 5, and that should be 9000, I believe. Okay, so that works out to 9000. What is the unit? The unit is given in centimeters, so the area will be in centimeter square. Okay, so when we have these calculations, we should use some tricks to calculate the square root. Okay, if we write the numbers inside the square root as factors of perfect squares, so we can have numbers which are repeating twice can be taken outside as well as a single repetition. So each pair can be taken outside the square root, because 10 into 10 is 100, the square root of 100 is 10. Similarly, 10 into 10 is 100, the square root of 100 is 10, and so on. So that way, if we simplify it this way and keep breaking it down, the computation of the square root becomes easier. Rather than if we first multiply all these numbers and then try to evaluate what's the square root, that will be a bit of a challenge. So you have to be careful how to proceed with this. And if you use some basic tricks, it will be much easier to do the calculation. So what we have simply done here is we have just broken down the numbers into their factors in such a way that we get pairs of numbers which can be taken outside the square root, and then keep simplifying it further and further until the square root is completely simplified. In some cases, like in this case, we have got all the numbers outside the square root and eventually multiplied them to get the area. Sometimes there might be some number left inside the square root, like in the previous case, we had some root 3 or something left out. So we'll keep that root 3 as it is. Okay, so this is one way of doing the calculations in a simple way. So you need to practice these things in order to be able to be fluent in working out these kind of calculations. Okay, so that is the end of chapter 10. So I've done some example problems in the previous video, and in this video I've done 3 problems from the exercise, and the other problems in the exercise are quite similar to these problems. So one should be able to do that, and if you have any questions, please do post in the comments, and I will try to post the solutions and explain the procedure if required. Okay, so that completes chapter 10, and in the next video we can proceed to our new chapter, which is on areas, surface areas and volumes.